Okay, here's the second part of 12.1. We're going to talk about frequency distributions. So we just talked about collecting data and collecting using random samples. And once we have that data, how are we going to kind of organize it? And so there's a couple of different ways we can kind of organize and display data. And so a piece of data is called a data item, and collected data can be represented using a frequency distribution chart. That's one of the ways we're going to do it first. Such a distribution consists of two columns. We have the data value are listed in one column, and then the frequency. How often does that data item occur in the other column? Okay, so one of the ways that we can display data is a frequency distribution. I'm going to give you some data, and I'm going to ask you to construct a frequency distribution chart. And so if you look here, this gives us the data of the age of maximum yearly growth for 35 boys. So they asked 35 boys, at what age did you grow the most? And these are the answers that they gave. So we're going to use this data to construct a frequency distribution chart. So in the first column, we're going to put the ages. In the second column, we're going to put how frequently the boys said they grew at that age. Okay? So going through the chart, I noticed that the lowest age looks like 10. It looks like the highest age is, I don't know, I see an 18 right here. So that's what I'm going to go ahead and do. I'm going to take my values. I'm going to put 10, I'm going to put 11, I'm going to put 12. I'm going to go all the way down and list all of the different ages the boys said that they grew the most. So 10, 11, 12, 13, 14, 15, 16, 17, and 18. Then I'm going to go back through my data and I'm going to figure out how many boys said that they grew the most when they were 10 years old. I only got one. You might want to cross it off so you don't count it again. Then I'm going to look to see how many boys said they grew the most at age 11. So go through, calculate how many boys grew the most at age 11. I got 2. Did you? All right. Go through again and figure out how many boys said they grew the most at 12, 13, 14, all the way through. You might want to pause your video, do that, and then come back and see if we got the same answers. I got 5 at age 12. I got 7 at age 13, 9 at 14, 6 said they grew the most at 15, 3 at 16 years old, 1 at 17, and 1 at 18. Did your numbers match mine? Okay, so I would like you to be able to fill out a frequency distribution, but I would also like you to be able to answer questions about a frequency distribution chart if I gave you one already filled out. And so how can we first make sure that we've listed all of the data and we haven't forgotten any or we haven't doubled up on any of the data items? Well, if you go through and you add up all of these frequencies, how many should we have in the end? Well, we should have 35, right? Because if we surveyed 35 boys, then there should be 35 total in the end. So go through, double check, make sure that you end up with 35 so you don't accidentally forget anything or double count something, okay? And so I'll be able to figure out how many people were in this survey by adding up the frequencies. And so now that we have this frequency distribution chart, what are some of the conclusions that you can draw by looking at this frequency distribution chart? Well, one thing I noticed is that the highest frequency happened right here of 9, and that was the age of 14. So I can conclude that when I sampled these boys, that most of the boys said they grew the most when they were 14 years old. The least amount of boys grew the most at age 10, 17, and 18, right? But the majority of boys said they grew the most between the ages of 13 and 15. Does that make sense? Okay, so one, you need to be able to make a frequency distribution chart given some data. And two, if I give you one already filled out, can you answer questions about it? Okay, so frequency distribution chart. Let's do another one. Here's example number 4. It says, here are the statistics test scores for a class of 40 students. So remember that number, we have 40 data items. Group the frequencies into classes that are meaningful for the data. So instead of doing it by individual scores, a 0, a 1, a 2, a 3, a 4, all the way to 100%, instead, for something like this, it might be more meaningful to group them together. How many students got A's? How many students got B's? How many students got C's? And so on. And so what we're going to do is we're going to list the test scores in what we call classes, groups, instead of individuals. And then we're going to list the frequency in the other column. So The first group we're going to do are the people that got A's, 90 to 100, or in this case, 90 to 99. Then we're going to do all the students that got B's, let's say 80 to 89, and so on. So finish filling out that column of your chart. So those are my different class test scores. I've got A's, B's, C's, D's, F's, and they've even split up the F's into 50s and 40s. Now let's go through the data items and list how many times a student got an A, or a student got a B, or a student got a C, and so on. So going through the data items, how many students got a 90 to a 99%? I got 5. How many students got a B, an 80 to an 89%? I got 9. Pause the video, fill in the rest of the numbers, and see if your numbers match at the end so you didn't forget anybody or double count. I got 5, 9, 11, 6, 6, and 3. Hopefully you got the same numbers as me, but what's another way to double check that I didn't forget anything? Yeah, remember, you should be able to add all of these frequencies up, and we should end up getting 40 because that's how many students were in the survey. That's how many students were in the class. Okay? So again, you notice that we kind of separate it into classes where you have a lower class limit and an upper class limit, for example, 40 and 49, where each of the class widths are 10. There's 10 scores in each of those little groups. Okay, so sometimes it's more meaningful to do these scores in groups instead of individual. Sometimes it makes more sense to do individual scores. But again, you should be able to take the data, organize it in a frequency distribution chart, and then be able to make conclusions about this. So we can conclude that more students got a C than any other grade on this test. We can maybe talk about how many students got A, B, and C passed the test versus failed the test. And then I can kind of compare, if I was a teacher, what I thought about the data of how many students got A's, B's, C's, and so on. Okay, so make sure you can also analyze the data after you've organized it.